So here's what we're looking at with a problem with these loading docks, where these trucks have come in here and hit this bumper. It's a 40-ton wrecking ball coming back. What we're doing, I've cut all this 1/2-inch plate. This is the first one, and a lot of the ideas on how this is going to be done were decisions that were made before I got involved. There's going to be a plate added right here, and then it'll be welded. And this will be welded all across here. To me, that right there is what's going to make it stronger. It's all about this right here, this corner, because when that bumper's put back on there and welded to that corner plate, and the truck hits it like this, that's going to be the key to see. This one's bent, even though it's not broke, and it's bent back just a hair, and it is broke a little in the back. But these two over here are bad. They've obviously, the rebar and whatnot in the concrete that's welded to that piece of angle iron there that's painted yellow, you know, that rebar has twisted and busted a hunk of the concrete out. So that's what we're into. A lot of plate, flat bar. It looks like these bumpers up here on the trailer, closer to the doors, stick out about 1.5 inches more than these lower bumpers. I've checked several of these trailers, and that's what I'm getting, about 1.5 inches on most of them. They're not all the same, obviously, but it's what it looks like on average. Those bumpers are pretty much where we want them. I ran that down, and it fits in between them. The next thing I'm wanting to put in place is that bumper. That one goes on there, and it's upside down. And they had mentioned putting a plate behind that, putting another 1/2 inch or something behind that to get it to come out farther so that the truck actually hits it. And if you look here where we got a trailer that's backed up to here, this lower bumper part on a trailer, that one's about 4 inches from hitting that bumper right now. So I'm going to run around the other side and look at the upper part of that. Okay, I'm on the other side because this bumper on the back of the trailer on this trailer is in good shape on this side. The one over there is about half tore off, so we're not going to go by that. We're going to go by this. But if we look at this, we already know that other bumper over there is 4 inches away. where we measured just a second ago. And if we look at this one, we're about 2.5 inches away. So all the other trailers that I measured also showed that that lower bumper piece was about 1.5 inches in from the upper bumper piece. So I think we want that lower bumper to come out 1.5 inches from where it was. This is the scrap that come out of that sheet to cut out that opening. And it's big enough to cut 3 pieces of that. This is 1/2 inch plate, so if I cut 3 pieces, that'll be 1.5 inches. And if I put them behind that bumper, I think it'll cause the trailers to make contact with all 3 of them bumpers at the same time. That should help a lot. Did you just see that dude catch that burning edge? I mean, that was cool. Like, that dude, he must be a ninja or something. Yeah, for real. Dude's a ninja. Gotta be. The guide I'm using is from Curvomark, aluminum with the magnets on it. When I worked in the oil field, we called it a whiskey stick. They work pretty good. Hey, I just shot some footage that I want to explain. I was pretty close to my welding machine where I was working, and it was too loud for me to talk while I was doing what I just did. I pulled a gap together in that plate to weld it up with a hot tack method that really works well. The method works if the timing is right. And what it involves is you're making tack. You need to make if you're doing this, you need to tack with 70-18, because you got to have the elasticity of that low hydrogen rod. It won't work very good with pipe rod. But you make your tack with 70-18. When you got a gap that's too big of a gap, you want to pull it together, but it's a small enough gap you can bridge a tack across it. Once you bridge that tack across there, you hit that tack and that plate with your hammer, and you've got to hit it when the tack is still hot enough that it's somewhat soft, but cooled down enough that it's not lava. It can't still be a liquid. It's right in between there. And what's taking place is you've got a gap, you bridge that tack across there, you hit the tack at just the right moment and it squashes the plate together, but the tack doesn't allow it to spring back open. And if that's done right, you can pull a gap together, and it's a very, very handy tool. It's very fast as compared to welding a dog on there, or a half clamp, or using some other method. And on longer plates, sometimes you'll run into a situation where one side of the plate is tight, and then you've got a gap, and the gap just gets wider and wider and wider to the point that it's too big of a gap to even weld. Now, on one of those, if you use this hot tack method and start over there where it's tight, Go a little ways where you've got a gap that you can bridge a tack on. Bridge a tack across there with a 7018, hit it with a hammer and squeeze it. Well, then you can go a little bit further and do it again, do it again. I've had plates, you know, long distances, several feet, with gaps that were too big but tight on one side, and been able to pull the whole thing together without a dog or a half clamp or pressing on it with a forklift or a machine. It's a method that really works good. It's a good one to know. I bet you Earl did that. He's a trickster. There's a tap con behind that was put in before these were glued on. Special made blade. Removed all the bolts, all the hardware off the front of this number one. Carbon arc the side bumpers loose where they're welded to that yellow angle iron. Next thing I'm gonna do here, I got to jackhammer out all that loose failed concrete. That's as far as I'm gonna go with knocking that out of there. Obviously, right here is where you can see a really cold seam in that concrete, where they poured up to here and stopped, and then from here to here is a separate pour. And the way them studs only go in the top, and this isn't connected to anything more than just that top 7 inches of concrete. So you can see here how I dealt with this on dock 5. The angle iron is flexed up right here where that bumper has been pushed back, and there was the failure. When I cut my plates, I get my 1/2 inch plate up there and get it in place, I can fix that. Very pronounced separation in that concrete. That's the first piece of rebar that I've seen on the ones that I've had to bust out. This is the 3rd one I've busted out. I've seen these studs on them, but that's the first piece of rebar. But obviously, if that rebar is not going into this slab, this thick wall, it's still a separated section. This one that I'm filming step by step, it's load dock number 1, but it's actually the last one that I'm doing. I've already done 4. I've come up with a little bit of a method the way I've been doing it. On these ones that I've got a jackhammer out filled concrete and mixed concrete and put back, the bags of concrete and the water and the mixer and stuff, the buckets and stuff that I'm using, I don't have it in the Super Duty service truck. I've got it in the old brick nose dually, and that truck works out really well for doing the concrete. I don't have the welding unit in the back of the old brick nose right now. I just got it set up as a flatbed with that concrete and stuff on the back, and it works out really nice where I can just back it right up. It's about the right height to back right up to that loading dock and kind of use it as a platform to have all my tools, and I got room to mix that cement, pour it in and deal with it and clean up my tools. And so that's what I'm doing right now. I'm in the Super Duty service truck, and I'm gonna head back and get that old brick nose dually and come back and do that concrete. Then I'll drive the brick nose back to the shop, use the water hose to do the final cleanup of whatever I used, and get back into Super Duty and go back to the loading dock and finish up with the welding fabrication work. That's what's up. Moving on. So you can see how having that plate there before I do the cement helps, because it's pretty much giving me a form. I just pour that full and do this repair. That'll work for that. Headed back to get the service truck. So each of these plates on the front have 4 holes, and then the flat bar across the top has 6 holes. So we've got a total of 14 1 1/8 inch holes that we're going to drill, and let's get to it. Got all them holes drilled, got the mess cleaned up from that. Taking a quick break, rest my arm a minute. I'm getting ready to epoxy them pins in them holes. I'm using the Dural Fast Set Epoxy from Euclid Chemical, EUCLID. This is the product that actually the construction company that hooked me up with this job, they had that. I guess they use it on anchor bolts and stuff. I found it to be a fairly fluid epoxy. It's kind of watery, and that would be great when you're setting a pin straight down in a hole. 8 of these go in a hole horizontally, and on the first one I did, I wasted a lot of epoxy because I had a lot of it run out. Going to explain quick the way that I've found that it does work well here. I actually will use some of those straight down drilled holes to apply epoxy to the pins that I put in horizontally. I'll put a bunch of that epoxy in the hole, shove the pin down in there, and get it really coated with epoxy, and that makes it so that when I shoot epoxy in the horizontal hole, I won't shoot as much. I don't have to, because a bunch of the epoxy's on the pin. Now, I will shoot epoxy in the horizontal hole, but it doesn't do any good with this product to stand there and pump a bunch in a horizontal hole, because it's going to run out. Like I said, it's a fairly fluid product. After these pins get epoxied into that concrete, I'll weld the pin to the plate. That's a thing that works pretty good. It doesn't leave a huge nut sticking up. It saves a little money. I don't like Hilti bolts or expansion bolts of any kind. I've been to rock quarries before and seen how they break rock, and the way they break rock and the way those Hilti bolts or expansion bolts work is pretty much the same. And when I was a kid in Charlottesville, Virginia, I was doing a job using those expansion bolts one time, and I busted a bunch of concrete. I over tightened a nut and broke some concrete, and I've thought about that ever since. This method with epoxying or using some kind of a construction adhesive in the hole, and then welding the pin to the plate, I just prefer it. I've been doing it for years, and I'm really happy with the way it works. My buddy Dalton, whenever we were talking about this one time, he asked me, he said, well, what do you think happens to that epoxy when you weld the pin? Well, I'll tell you, like I told him, I think the first inch or so probably burns up, obviously. The thicker the plate, probably the less it's going to have an effect on it. But I don't think that it destroys or damages the epoxy glue or the epoxy seal. In a case like this, where I've got a 1-inch pin and a 1/2-inch plate and it's 8 inches deep, we're really counting mostly on, that 6 inches from the bottom up to be where the strength's at. If an inch or two of that epoxy burns up there at the top where I welded it, it's like whatever. I'm good with it. I think it's great. I think it's a good method, and I think they'll find that this works really well. This epoxy, this fast set, the foreman or the boss or whatever from the company that I got this from, that turned me on to this work, he was saying, well, man, you only got minutes with that stuff. It'll set up on you and you can't use it. I haven't had a bit of problem. I've had plenty of time. But listen, if you use any product that's a fast set, and I like fast set products. The rapid set cement products are my favorite cement products on the planet. And those rapid set products, they set in 15 minutes and they're structural in an hour. But with any kind of stuff like this, just get all set up. Before you mix something, before you get rolling, make sure you're all set up and good to go. You can't be tripping and lollygagging once you've got something mixed. I like this epoxy. It does set fast, but I have no problem using it. I like to use regular construction adhesives at times too. If I don't need a fast set product, that stuff's a lot cheaper and it's a lot more available too. You can go to Lowe's or whatever, get some like Gorilla construction adhesive. Liquid Nails makes some good ones. There's a new one, Liquid Nails. I can't think of it right now, but there's a new construction adhesive that they have that I've used. I'm really happy with. But anyway, this is the next thing I'm going to be doing here is epoxying those pins in those holes. And I'll do it, like I said, I'll soak the pins in the epoxy using some of those holes that are straight in. And, then I'll shoot some epoxy in the horizontal ones, pull the pin out of the vertically drilled hole and slide it in the horizontal one. And that technique has been working really well. So that's what I'm going to do. That's going to be the next thing. And we get rolling on that. I'm just taking a quick break. I was going to make some notes on that because like a lot of stuff I do, I'm not going to be able to tell you what I'm doing while I'm doing it because I'm busy doing it. The forklift there, the telehandler is going to be cameraman, so we'll see how it does as cameraman. All right, that's next. So this is a two-part product. Use a standard caulking gun and it mixes in this tip. I'm using 3 tubes on one of those. I don't use the same tip. You want to save a few of these if you can. This one here I didn't need. I only needed one. I just took it off the used tube and put it on the new one and kept going. But now I have an extra, which you might want. You can use a half of this, put the plug back in it and the cap back on it, and save it. I've done it. It's fine. As long as these two parts don't mix, it won't set up. And then later, if you've got extra ones of these, you can use it. You use the rest of a part of a tube. I got welding rod stubs tacked on that rebar just to give me a way to hold on to it during installation. And I'll tack these up and then I'll cut those welding rods off there. At a stopping point with the welding right now, because with these bumpers on here we can do some more cutting and fabrication work. There's plates that need to be cut. There's a plate that goes right here, fill in that area. On each side there's a plate that goes right here behind this bumper, pretty much as a gusset. Need that for both sides. And then there's going to be 3 plates cut that go behind that lower bumper, that shims that lower bumper out 1.5 inches, like we've got right here. And it's really efficient the way this is worked out because of the 4x10 sheets that they bought. Now that piece of steel right there is the piece of steel that I cut out when I made my cut for that opening. And by the time I cut that up for the pieces that I need right here, it's pretty much gone. We use almost every square inch of that sheet. So that's next up. So the last part of this is these tabs that hold the hydraulic lines and the conduit, like I've got tacked on here. I do that with a 3/32 pipe rod. I got some 3/32 5P plus, and I just now plug weld through that hole. So we're going to be turning her down quite a bit, and that's what's cracking next. That'll finish us up on this. Looking good on the structure. Welded up good enough. Get this little bit of tabs put on here for the conduit and the hydraulics, and that'll be it. So that's all of them. We're loaded up. Let's head on back to the shop. This one's done.